In this video, we want to talk a little bit more about the cross product and start talking about some things we can do with the cross product. First of all, you see it says for each of the following, find A cross B. Well, I made this kind of tricky on purpose. You see that I put B first and A. The order does matter here, but let me just explain here what the difference is going to be. Let me do the first problem just down in here. Okay, so we've got I and J and K. So it's A cross B. So you should put A first, like that. And of course, we start with I. So when we do -10 minus 5, that kind of determinant. So I'll just write that I. And then -10 minus 5. Remember, J is always subtracted. So we've got J, so we've got -5 minus 15. And then K. So we've got -1 minus -6. All right, so we've got -15I. We've got -20, but with that negative out front right here. So it's, see, it's -20, but this means we do the opposite. So we've got 20, J, and then we've got -1 minus -6, so we've got 5K. If we reverse the two, and maybe in the interest of time I won't, but if we reverse the two and actually did B cross A, all of these would just be the opposite sign because we would have switched our subtraction, so it would have been -5 minus -10, which would be positive 15. 15 minus -5, but with the negative out front would be negative, and -6 minus -1 would be -5. So if we had done B on top, B cross A, they would simply be the opposite. All right, let's do the second one. We'll do it right here. So N, I, J, K. So 3, 2, -1. Okay. So I. It's going to be 4 minus 0. J will be 6 minus 2. Zero minus -4. So I've got 4, -4, and 4. And again, I is 4. Here is 4, but we have this negative out front that's applied. And here it's 4. So there's our cross product. So as a reminder, we had these couple of different ways of calculating the cross product. We really focused on this one, right? We talked about using a matrix and doing the determinant. That is exactly the same as this formula, you know, where we cross minus this. You see that right here. This minus this. You can see that right here. This minus this. You can see that right here. We didn't focus a lot on this, but in the previous video we talked about why it was sine. It's because if you remember the picture of the boat, we had the boat going across the river and the forces working on it this way. So we wanted to know, how this opposite force was working, and we against the hypotenuse. So that's why it was the sine. And we just kind of showed that this formula dealt with sine and these magnitudes. Okay, so we're going to kind of focus on this formula for just a minute so we can talk about how this could be useful to us in three-dimensional space. So I want to talk about the relationship geometrically to parallelograms. Okay, so if you remember from geometry, the area of a parallelogram is base multiplied by height. Okay, well in this case, the base of this would just be this vector b. Okay, that's easy enough to find. You say, all right, so magnitude of b is the base. Now the height, well of course the height is parallel. So you think, well, I would really need to know this angle, right? And that's how I would calculate the height. I would do the sine of theta equals opposite over, and you'd need the length of that a, so magnitude a. So you could cross multiply or multiply both sides by that. So putting that in place, you'll see our cross product formula. Okay. Now, you'll notice here, this symbol, of course, means magnitude. It's the magnitude of the cross product. Now, I want to get away from thinking Pythagorean theorem, and I want you to think about really magnitude just means length. And here's why that's going to be important. I want to show you how we could apply this formula to find the area of a parallelogram. We have a vector down here, 2, 1. We have another vector, 1, 3. Okay. Now, to cross a vector where there's just the 2 dimensions, we really just do the determinant the one time. We say, okay, well, 1 minus 6. Okay, so this determinant is just 1 minus 6, or negative 5. Okay, so remember, magnitude doesn't necessarily mean Pythagorean theorem. Really, all it definitely means is length. So once you have this calculation and you say, well, remember, this was my area of a parallelogram and it's equal to the magnitude of the cross product. My cross product was negative 5. The magnitude of that, simply the length of negative 5, is just positive 5. Okay, you want to think about it from a Pythagorean theorem standpoint. You could think that, well, I took negative 5 and I squared it, and I took the square root. Okay, so this is a way we can use the cross product to help us with some geometry. And this is the geometric interpretation of cross product. It's dealing with this the sine angle, so it helps us with this parallelogram. However, I would like to see how this works in 3 dimension and really how it can help us there. That'll be in the next video.